Shared work problems are a common application of rational equations. In this example, we are talking about an experienced and a beginning roofer, and the first piece of information we're given is that together they can roof a house in 18 hours. So we're going to fill in this table involving time to complete the job, because this is the information we're usually given, and fraction completed in 1 hour, because this is the information we're going to use to create our equation. We have an experienced roofer and a beginning roofer. So the first thing we need to do is come up with meaningful labels for our table. And at the bottom we're going to put together. This is where we always summarize the time that it takes them to do the job together. So the time working together in this case is the information that we are given in this problem. Working alone, the beginning roofer requires 3 times as much time as the experienced roofer. So the way I'm going to use this is to say if the experienced roofer can complete the job in X hours, the beginning roofer would require 3x or 3 times X hours. Now, the way that I go from here to the fraction completed in 1 hour is by taking a reciprocal. If the two of them working together complete the job in 18 hours, then that means the two of them working together would complete 1/18th of the job each hour. So following that pattern with my variable expressions, which are less intuitive, I would go ahead and make these into 1 over x and 1 over 3x respectively. Next, I create my equation based on what happens in 1 hour. So in 1 hour, I would add the contribution from the experienced worker, which is 1 over x, 1/x, if you will, of the job, to the contribution from the beginning roofer, which is 1 over 3x. And with the two of them working together, they should have completed 1/18th of the job in 1 hour. So this gives me my equation, and from here I want to find the LCD and use the LCD to clear the denominators. The LCD now is 18x. Since 18 is already a multiple of 3, I have the 3 already covered by this. And I'm going to multiply both sides of this equation by 18x to clear the denominators. After this step, I can see that what I have remaining is, on the left-hand side, 18x times 1 over x. The x's drop out, and I have still an 18. Looking at my second term, 18x times 1 over 3x, the x's drop out, and 18 divided by 3 gives me 6. Looking at the right-hand side, I'll go ahead and do my cancellation with red now, since we have only one product to do. On the right-hand side, the 18's drop out, and all I have remaining is x. So in this case, after clearing the denominators, our equation is just incredibly simple. All I have to do is add 18 plus 6, and I'm already done solving. This is the time working together, or the time for the experienced worker, rather. So I still need to find the time for the beginning worker, which is 3x, and that's going to be 72. So these make up my two answers. The experienced worker takes 24 hours to complete the job. It's important to note that mathematically what we are assuming in order to do this problem is that these two roofers would start from opposite corners of the house and work exactly the way they would work if they were working alone towards each other until they meet, that they each have their own tools, that they're not sharing anything, and that they're also not doing anything to improve the efficiency. In real life, that is probably not the case. Many times the beginning roofer might be doing some more routine tasks while the experienced roofer is able to use his or her skill more to the point. But it's important to also appreciate that as a base case, this is still valuable information. Compared to this base case, one could figure out whether they think that they will, in practice, be more efficient or less efficient than this kind of standard just splitting up the job case, and be able to adjust from there to get a reasonable estimate.